Well, welcome to the Structural Modeling video conference for May 4th, 2019. Today we're going to be talking about applied natural language relationships and how those fit into structural modeling and structural modeling events, and just in general how things kind of fit together at a higher level, and then drill down into some more of the technical details. So today we'll be looking at a scenario where let's go look at the augmented interactive management steps. Look at these for just a minute here, refresh your memory what these are. So these are things that happen at a structural modeling quote unquote event of some kind. And so there's things that happen before the event, and there's things that happen after the event. And most of what we've been working on recently is focused on the area of structuring ideas, either amending ideas, structuring ideas, and amending idea structure. So most of the mathematics and the logic have been focused there. Bottom line, what this is about is that classically there was just a logical way, a logical inference to manage the data and the structuring process. What we've discovered and we're proposing is there's two basic approaches. The second basic approach will have multiple components to it, but we'll have the logical structuring assistance when the natural language relationship is the proper logical type. And then when the natural language relationship is not the proper logical type, then we can just use the computer to help manage the data. Because we get information from two places. We get empirical information from the group, and then we get information that's inferred using the logic. So if the level of logic and the type of logic we're working with doesn't match the logical properties of the natural language relationship of the predicate, then we'll just use the computer to manage the data. And of course, the whole idea now is once we have the AMEI, the Augmented Model Exchange Isomorphism, and the abstract relation type, is to actually find higher level logical types that we can apply different types of logic to and identify them, and then leverage that logic later on once we've developed the specific types of logical rules that are necessary. So that's kind of where we're going. And again, we have, prior to this set of steps, which is kind of in the event, we have steps that happen before that. These are some of the things I think that Kevin has in his playbook. And then we have steps that happen after that. And that's, we say, well, how well was this event? Did it meet our expectations? Do we need to do other things? Do we need to try something different? Instead of an event, maybe we'll have a continuous application of these types of structures all the time throughout our organization. Things like that. So there's, we just really wanted to place this a little bit more in context. Okay, so now let's go back here, take a look at one more time. That's kind of the context, and this is the overview. Now we'll talk a little bit about structural modeling, the predicate logic, the informal to formal transition, what that means, what are the challenges there, how we expect to deal with those in the future, and then key application steps, and then augmented interactive management, about 5 minutes, and then summary and wrap up. I'd like to get people's input on what they think about the specific ideas and approaches. And of course, if as we're going forward, you can feel free to ask questions at any time. Okay. So with that, let's go ahead and start looking at the paper. So the key idea here is that we're applying some structure in an organization, some organizational structure, some semantic structure, some process structure to help large dispersed groups of people better understand the type of problems or situations they're dealing with, to structure those problems and ideas. We do that by using natural language. So you get a group of 30, 40, 50 people together. They all hopefully speak English. But that's the idea, is you need to have a common base natural language for them to work from. And then working through the process of the analysis, the structure itself, the structure of the problem is determined by gaining knowledge, empirical knowledge from the people in the event, from the people in the organization. And then once that base information and empirical knowledge is put together, then work through the relationships between and among these objects that were developed using empirical observation or empirical questioning. So when you start looking at the relationships among these objects, working with those, then essentially what we have is we're looking at can we apply predicate logic to infer information, proper information from the collected data set, the empirical data. What we noticed when we went through it is basically that in the demonstration, we augmented in the handbook of interactive management, that there was only 2 examples, well, 3 examples, but they expressed only 2 logical relationships that were fairly well defined. But those, but the literature where people applied these techniques using the software, the natural language relationship seemed to have completely different logical properties and application properties than the ones that we use to demonstrate the software. And we've been looking at that for a while. We developed the abstract, the augmented model exchange isomorphism and the abstract relation type to help organize the data and information just associated with that particular observation. And what we believe is happening is we have 2 basic types of structural modeling language, natural language applications at this time. And so one is the ones that come out of interpretive structural modeling, and they need to be put in a context that you can apply the standard predicate logic to them. And we've identified those. I think there's 2 groups in the AMEI, the logical property groups that applies to, but then they also need to be global, also need to have a global contextual property to them for them to actually use standard predicate inference. The others, everything else now is we can get the information from the interpretive structural modeling activity from these people, and we can bring that in, and we can manage that using the computer. We can manage that data, but if we want to use logic, we are going to have to develop higher order type theories to address these different groups. But now we have 27 groups, and we identified 2 of them and said, okay, you know, under certain circumstances, we can use just standard predicate logic. Under other ones, then we say, well, can we identify certain logical types that allow us to, again, use inference again? And I think that is highly possible to do that in many cases. Probably not in all cases, but it's probably doable in the long run. But what that does then is it allows you, again, to apply the specific type of logic for that specific logical group. And those are higher order logics, of course. They're higher order logics in the type theory. Okay. So another interesting fact I wanted to point out was the fact that, you know, Boolean and algebra and logic basically is at the nominal scale. It just has a name, true or false, 0 or 1. And the operators equal or not equal, and the primary purpose is grouping. And we see that quite a bit in the, you know, in the published literature where people will classify things. So you classify things as grouping. But then another thing we also see is we're placing things in order. So ordinal. Well, Warfield augmented Boolean algebra with greater than or less than operators. But the Boolean algebra, then what this does is that it helps when you're working with natural language relationships or logical predicates that are that create an order. And so again, we have the ordering process going on, and that is a very important step. But we pointed out here, there's some people that that interpreted the ISM techniques and published techniques that were further up the logic of the measurement scale. Hitchens did the Sade method, which basically is ratios, and people are not very good at doing ratios at all. And also Stewart version ISM events were allowed to precede themselves. So it's an ordering, but it's an ordering that doesn't make any rational sense. So it's, again, challenging, but want to point out that it's important to match the logic of the natural language relationship or the predicate with real world experience so that you're getting useful inferences from the information. Okay.
Yeah, Joel.
Yes.
Just a comment on the ordinal operators you had just a page or 2 ago.
Yeah.
It's this one. So it says the ordinal scale operators greater than or less than, and is it that it's the greater than symbol and less than symbol, but it's not necessarily restricted to being applied towards like 3 is greater than 2, but that it's something that's implying an order of some sort.
Yes, it is. And so, and the greater than and less than symbols that Warfield added didn't necessarily apply to the natural language relationship or the predicate, but that apply in the mathematics where, let's say, for example, they're using an abstract relation type that had multiple matrices, right? And it had an operation over the value. Let's say I have 25 value matrices, and I'm doing an operation on those, that group, then the greater than or less than symbols in Warfield's Boolean algebra would apply there. So yes. Okay.
Joseph?
Yeah, Jack.
Down below 2 pages where it references Sadie's work on ratio scales, I just note that it was a common recommendation to use, I believe it was at one time, to use these greater than, less than operators from Warfield as part of ISM to get an initial ordinality, let's say, to a group of objects prior to doing the more specific ratio scale work that Sadie does with the analytic hierarchy process.
Well, that's good to know. I'm just looking at it basically from the information that I have available. That's new information for me, but it also indicates a process chain, right? And I would just say that if you decided that it was appropriate to ask people to give their impression on ratios and how things work, that just as you say here, that people are very bad at doing that. They're good at the ordinal scale, pretty good at putting things in order. They're bad at interval and they're bad at ratio. And so, in that case, then you might be introducing some data that was maybe not quite as, or information that's not quite as solid as information to develop using the ordinal scale. But
they're just suggesting that the ratio scale results would improve if you did the ordinality first.
Okay. Well, yeah, that
Anyway,
makes
sense. Excuse me. It might be better to say that rather than that they veered away sharply, that they perhaps moved into higher order processing before they made sure that the foundations were as solid as your work is. Your work is ensuring that the foundations are solid, and then one could consider the judgments of ratios and impacts. But maybe you should moderate your phrasing there. that they if they did acknowledge Warfield, then maybe it's that they're going too far too fast, rather than that they're not following him.
Well, I guess that's a good comment, Janet. I would say that again, just in my conversations with Warfield about these two specific examples, he he reviewed both of them. He reviewed Hitchens' work, I believe, and he just told him it was completely different than what he was doing. Warfield was doing logic, and ratio scales are not logical implementation, and so that it wasn't, even though the matrix kind of looks the same, that's not what was going on. So that was they had, my understanding is they had some conversations there about that. But it's just to say that the primary part of dealing with this is that you need to have some foundational pieces that are solid, like you said.
Right.
So anyway, there was quite a bit of, and as far as the other one goes, it was interesting, I think, in the first DSM conference at MIT, Moorfield was invited to present there. He got best paper, and he said he talked to the folks there about it, and they basically realized that it was, had tremendous issues, but they already had too much stuff, too much energy and so forth invested in it, so that they were going to continue going that way. So
Right. Okay. Yeah. All of that is informative. That it's they appear similar, but they're different.
yeah, they're very, very different.
Yeah. Mm-hmm.
That's one of the reasons why. That's actually one of the reasons why I've gone through this and taken it apart to kind of look at it. And now I think once we've taken it apart and looked at it, we have a basis which you can build up different type theories, which should be interesting. Anyway, so yeah.
Joseph,
Yes, Jack.
could you say a few words about the units of measure?
Sure.
It is greater than mass or time or what?
Oh, okay. Well, so let's say we have what that's really, really good. Okay, so what you asked about greater than or less than, you said mass or time or what? So those are nouns. Mass is a noun, time is a noun, right? And what we're doing in the natural language relationships is we are talking about the relations between these nouns, right? And so if I have a structure, if I have created a structure, a system structure with value system 1, and I've created another system structure with value system 2, what I'm doing is I'm relating those structures together, saying, oh, on some value scale, structure 1 is greater than structure 2. And so that's
but on a different one, structure 1 will be less than structure 2.
Yeah, it just depends on your value system. But what it does is it'll in the Boolean space where I just have zeros and ones, right? It gives me the opportunity to say, oh, if in the lower triangular section of this matrix I have 27 1, my total is 27, right? And in this matrix over here, my total is 10. Then given my value structure, I could say, oh, 27 is greater than 10. Or maybe it's the other way around. Maybe under the value system, having less is better, right? So it's just that type of operation that you can't do, without the greater than or less than. But it's interesting. Okay.
Joe, excuse me, but I'm getting a lot of background noise. I can't hear.
Oh, that's not me. I'm not sure. Yeah, there.
Oh, there we go.
Yeah.
Thank you.
So natural language relationships and predicates. So this is kind of where we start saying, okay, really our natural language relationships can be treated as predicates. And what we've done now is, over a period of time, is looked at these in a number of different ways, but we have talked about the logical properties of these predicates. And the AMEI does 27 buckets of those properties together. And then that makes even, so that is now, once we have these groups, that's a property of a property. So we're going up to third level and higher order logics. And you need to, apply special types of logical operations to those specific higher order logic, which may be a fruitful thing to think about and go forward on. But the other thing I'd like to highlight here is that in the abstract relation type, we have prose, structured graphics, and mathematics. And given the mathematics where you have a binary matrix representing the structure, a 0 or a 1. It's like it's connected or not connected, right? That mathematics, that binary matrix, can represent empirical data that is not, that you cannot use for logical inference. So that you can represent it mathematically in a binary matrix, but you can't use it for standard predicate logic inference. So if we have to create higher order logics to deal with them, then maybe we can create a logic that says, okay, now I can, or we can use we have a logic that we can use for inference for every one of these that makes sense in the real world. So we can get empirical data, map it into a binary matrix, and that binary matrix, where it sets some of them right now, we don't have the logic formulated to be able to use inference on. And the whole key thing, what we're saying here is, okay, some of them we know we can use inference on, so we'll identify those, we'll create the software to do that, and then we'll create the software to manage all of the empirical data and output from all the other things, all the other activities in the event. And then we'll hopefully add software to manage the pre-event activities and the post-event activities. Okay. So basically, the idea of north of, relationship is irreflexive, asymmetric, and transitive. And that's one of the solid logical groups that you can use if you have, if it's global. And so north of is global because the artifact we have that we all have a shared picture of those, mapped over the space, right? Is that north is one way, south is the opposite, and east to west are perpendicular. So that is an artifact that basically mediates the interpretation by everyone globally. So that makes it a global type of relationship. And then,
so Michael and I have a question about that example.
Sure.
That relates to what Jack was raising there of the question of the variability of an interpretation. So you're talking about magnetic north. Are you talking about the possibility that there's variation in the identification of what is north, at different times, or as the the axis? But Michael, why don't you explain? Or the shape of the Earth is distorted by.
Right, Jenny's capturing it. As the shape is distorted or axis tilting, things like that.
Sure, yeah, that's really a good observation because it depends on our tools, right? Our tools that we're using to basically determine the value of north, right? But the mental concept, right? The mental concept we all have of north, south, east, and west, right, is the same. Now you're talking about, how do I precisely measure this? And what tools do I use? And what specific interpretation? But I mean, even on a map, right, on a topo map, right, I have magnetic north declinations, right? I have all these adjustments for these different tools, right? But still, north is north. I mean, that's a concept. North, south, east, west. That's kind of the big, mediating artifact that we all share, right?
Right. So it's not so much that north isn't an empirical fact. It's a conceptual fact that's relative to your context of your tools and conventions and agreed upon interpretations, as you say.
Yeah,
Um,
it's, yeah.
You know, once you get into,
Well, your mic went off, Janet. Okay. Well, anyway, so yeah, that's basically, you know, it's just a high level type of shared concept, a artifact that's been.
okay, I'm sorry. I was trying to speak. My mic went off. So you're saying that that North isn't an empirical fact. It's a it's defined. It's a concept that is defined in a context of agreed upon conventions and the tools that you're going to use, and the interpretations that you're going to share. So
Yeah.
you're getting back to your the group. The group has to have a common understanding, and then within that context, then North A is north of B. I guess the concern was to clarify that nothing is precise in empirical relationships. You know, you have to make certain judgments in order to get to that precision that will allow the formalization, and that's a matter of the context, as you've been saying, the group deciding the context.
Oh yeah.
Yeah.
Of course.
C.S. Pierce just rolled over in his grave. Is the way you use the idea north, is that the label for something or the something?
Well, that's an interesting concept, but the idea basically is the idea of north, south, east, west. So when we talk about north, we're talking about in the relationship to this planar type of map, right? North, south, east,
So
west.
nine is north of 8.
Well, I have no idea. And
Well,
so
but the point
basically,
Janet's, I think, is after is we've got to be careful we're not confusing the map and the territory.
right.
So when you use the term north, it seems to me you're using it as a label for the relative position of something.
As everyone in the group that reads the word north or understands the word north, you know, because we're working with a group of people, they have to have the same type of mediating artifact. They have to know this picture. North, you know, is up, south is down, east and west, right? Of course, the other thing that was brought up when I talked about cities is people say, well, how do you know, how do you know? Is it the center of the city? Is it the most northern part, the more southern part? You know, how do you know, if one city is north of another? Well, again, in that specific case, you'd have to say, well, maybe it's an area of, the center of the area moment of inertia or whatever you want to do, as long as they are constant, consistent.
Well, when I'm standing in New Zealand or the islands south of Australia, north is down, not up.
Okay.
Right. North is up and south is down in the way we conventionally orient our maps. Yeah.
The we north of the equator.
Right, and it's
but I
it's
can
a
assure
map.
you that
Yeah.
the
And
people.
all we're doing is normalizing our mediating artifact.
Right. A very good point. See, that's an excellent point, and you should have a whole section on that. Yeah.
Okay. But that's really good. Good points all the way around. Kevin.
Can you hear me?
Yep.
Yeah, there's I for some reason I can't hear Janet nor Jack. I'm not sure if that's what's getting produced onto your video for archives, but you might check it out. But I wanted to just offer, all I caught was a piece of you saying that people need to have an agreement on the relationship. And there's another school of thought besides them agreeing, having a common understanding. And that is through a collective, people bring all different nuanced understandings to the thing. And the aggregation, the act of the aggregation technique, which is usually voting, sometimes it's consensus, which is different than voting, is what brings the meaning to the relationship. And it doesn't necessarily have to be an agreement on the same meaning.
Yeah, that's really good, Kevin. And I think that basically that's what happens during the engagement in the event, right? You start out with something that kind of everybody kind of at least relate to, and then as people start relating to it, then you start refining it.
Yeah.
And so a very general artifact, mediating artifact, then becomes very specific for that context.
Yeah. I was in many events where people would be there'd be the explanation of the triggering question. We'd go through all the generation of ideas, and then the explanation of the so-called generic question or the relational question. And people would take a long time to answer the first question because they'd be trying to figure out kind of what the relationship means, even though it's been explained to each other, even though it's been given to them in a report 2 weeks ahead of time. And they spend a long time on it, sometimes 20 minutes to answer the first question. Then they get through a few more questions, and then, like by the 6th or 7th question, they suddenly realize that one of the reasons that they've had difficulty answering yes or no about the existence of a relationship is because they needed to make a stronger assumption about the context of the situation. And once they agree on the context, the answers to most of the rest of the relational questions speed up. They get faster and faster. But sometimes once they realize that, they want to go back to the first 6 and re-answer all the questions.
Well, that's really good, but that's kind of like learning. That's group learning going on. The individuals themselves, they're trying to figure things out at first, and they're just a lot of conceptual, a lot of real heavy intellectual activity going on. Then they start communicating and talking to each other, right?
Yeah.
In a structured way, and then the patterns and the habits, the mental habit starts to build. They start getting that pattern, and then they take off.
But something as what seemingly straightforward as influence, there's A influence B.
Yeah.
Right? And
yeah, no, I totally understand.
People can get into a thing where there's a presumption by a big part of the group that an underlying precedence relationship is involved, right? That if A influences B, it implies A comes before B, right? But does A start before B starts? Does A have to end before B starts? Does A end before B ends? They get into questions like that. And then you even get things like, well, would the anticipation of A propel B, even if A doesn't come before B? If we knew A was going to be done in the future, would it influence what's going on B? And people can create quite complicated morasses of implied relationships from seemingly simple logic.
Well, I agree. I've seen it many, many times. But in this particular case, the normalization of the idea, right? I think everyone here kind of understands in general how these relationships work. The important part is to use these as a guide as they're effective, and then to decide whether or not, if you get into these nuanced questions like you're talking about, and they're very important, then you may have to change the logic a little bit, or just record the empirical data and work with that. So it's and not be able to use inference at all. I think that's in many cases inference probably the standard, predicate or first order, second order predicate logic is not going to work well, but higher order logics and types might. And so that's the kind of the message here today is just that yes, we using the tools we've developed, we can say, well, okay, there's like classification or equal to. Well, that only fits in one group: reflexive, symmetric, and transitive, and it's global. Okay, so that is a good logical group to use for inference in predicate logic. And then irreflexive, non-symmetric, and transitive. It's basically an order. And this is another group. It's sort of like heavier than. That's global. It's basically a linear order. So that's another good one for inference. Now, something like when you talk about influence, influence could be in any one of these 27 buckets. Could influence things that way. So now, on one hand, the AMEI, you could say, well, I only mean influence with basically irreflexive, non-symmetric, and transitive. So if that's what you mean, that I mean influence with only these specific logical properties, then you could adopt a convention where you attach, these subscripts to that word, and then it would better define it. So just having influence by itself, right, is non-specific. By using the MEI, you could identify it and make it much more specific if you wanted to. Okay, so let's see. So basically, that's what we're talking about, the degree of focus. It's either specific or non-specific, or it has, two or more groups.
I'm missing the minimum dispersion value is 2. Why isn't it 1?
Okay. So the minimum dispersion value is well, if you have a relationship that fits only in one, right? Only in one group, then we call that focused, not dispersed, right?
Okay. I thought you were meaning dispersion as the general term. Okay, so you mean the minimum non-1 value is 2. Okay, thanks.
Yeah, it runs from 2 to 27. Because I got 27, so
Right.
you could have, and so the part of is the one that basically can have 2, right?
Right.
And that's what we talk about here. But in the idea of natural language part of, they talk about really the context of parts of a system that have, 2 or more parts, or something is a part of itself, which you're only talking about one thing. So that puts it in 2 different classes. So it's dispersed, but you can pick either one. And what we pointed out here is if you pick the irreflexive, asymmetric, and transitive, you can use logical inference. And then during your analysis of the process, it's really important that you add the reflexive component. You can do that just by adding the, in the mathematics area, just by adding the identity matrix. So that would basically, it's a technique that you can use to, when you're working with a group, the empirical information, if you use irreflexive, asymmetric, and transitive, then you can use inference because it's global. And then once you're done with that, if it's important to actually say that something is a part of itself, right? Every piece is a part of itself, then you can do that by just adding the identity matrix and again speed up the operation. But those are the types of things that the abstract relation type was designed for. You can document these in the abstract relation type for part and part of, and then that gives a common understanding for people that want to use that. Okay, so about 9:45 right now. So anyway, let's go through this. I think people pretty much. So here, it's with the older version of the properties of symmetry. It's the newer version where we made the single thread, and so it's global. So if this basically, you have multi-threaded pieces, you really can't use logical inference because some of these are not connected. Whereas in the single thread, they're all connected. And so again, if you have single thread, that's global, multi-threaded, and then the network, of course, is again challenging because for the predicate logic, because everything is in a network. Now, the network pieces is where you can use computational, evolutionary computation, and other types of machine learning activities to evaluate these networks. So you could actually, in this particular case, when you made a single thread, each one of these clusters then, once you've got them in their structure, can be evaluated using other techniques, and plan on adding that to the software. In fact, they did all of the clustering and the evolutionary computation techniques before we started on the logic piece. So that pretty much, most of that is in the can now, but let's see how it goes. And then we have the abstract relation type, of course, which you can use to represent more carefully all of these propositions. And in the examples, this is just an example of part of here and why it's not, why reflexive is not good for logical inference.
Can I slow you down? Actually, I think this is a really excellent report here. There's so much that's summarized and built upon really well. I think that's why we're slowing you down so much. But I wanted to ask about above the abstract relation type, figure 5. So you say a specific natural language relationship may be associated with at most 27 of the 54.
Right.
Now, is that because the scope attributes are outside of the association between the natural language and the logical properties?
Well, yeah, so let's take, for example, exactly, it's a scope, it's the local and the global. And so if I have a irreflexive, asymmetric, and transitive, that's a global single thread here, right? You say, okay, so that's single threaded and it's global. And so that will basically allow this to happen. If I have another multi-threaded one here, I could have the same relationship, right? I could have this. These relationships could all be irreflexive, asymmetric, and transitive, but it's multi-threaded, right? So you've got the groups, you've got all 27 groups, right? But it's either going to be multi-threaded or single-threaded. They're not going to be both.
Right, and I'm wondering, is it helpful to think that the threading and the well, let's take one at a time. So the threading comes from the relationship between it's the relationship type as realized in particular empirical data. So it's not intrinsic, whether it's local or global, multi-threaded or single-threaded, is it happens between the relationship type and the particular data rather than being intrinsic to the relationship type.
Yeah, it's not related to the logical properties of the relationship type.
Right.
It's basically another property that comes from empirical data.
Right.
It's a scope property, either global or local, that's associated with the empirical data. Correct.
Okay. And then the dispersion is a matter of, where does that one come from? Would you say from the judgment of how to structure the analysis?
Yeah, so basically you could have, let's say, for example, say maybe something's important in engineering is like connected to, or in logistics, you have a logistics supply chain connected to. As we've seen, connected to can operate in all 27 of these groups. So first of all, that is connected to global or local. And I would argue that connected to is local. So you just have a connection between A and B. And so then you can use the logical cube, then this grouping, you can use this to decide, or to say, well, I only want these specific kinds of connections. So then you can annotate the pros with these logical group subscripts to basically say, okay, I only want this version of connected to. And depending upon the version or the number of versions that you pick, then you may or may not be able to use logic to infer other components.
Mm-hmm.
Does that make sense?
Actually, I got stuck thinking about connected to. That's so connected to is a good example of, is that meant to mean there is a direct flight from A to B, or that it is possible to get from A to C? The transitive closure of the relationship. Is it directly connected or is it ultimately connected?
Well, that's really a good question. So you wouldn't have transitive closure in these over here that are intransitive.
Right. Right. So if it's important to maintain the intransitivity for some reason.
Right.
Yeah, this is all very well laid out. I'm just really appreciating it, and I'm sorry I'm keep interrupting your presentation. But
oh no, that's fine. That's fine. I just wanted to get through and give us time to talk. So it's fine. It's good. We'll just talk as we go through it. I think we're very close to the end here.
A quick question for Kevin. Kevin, did you hear Janet's comments just a moment ago?
No.
No. Okay. Thank you.
Interesting. Okay, so went through and showed that basically the issues with this particular form of predicate logic, and then why we would really need to develop logic, different types of logical types for each one of the buckets. And the informal to formal transition just spells out the mathematical relationships that you would need to put things in proper alignment. Start from ISM with the natural language matrix, the matrix processing, and then we create an enhanced reachability matrix, which is the input to the basic structural models. And this enhanced reachability matrix is where we adjust the binary features of the natural language matrix so that the mathematics will do what we want it to do. And we do the matrix operations, do whatever calculations, inference, summing, variations across different abstract relation types that could have multiple matrices in them. And then we leave the basic structural models into the enhanced reachability matrix output. So again, modify whatever needs to happen there in the matrix processing, then back to the natural language matrix and the final output, and then give it the natural language. So it's just a general pattern that we demonstrated early on of how that could be done. In summary and conclusions, so it's basically that got rapid change are going on, but the methods and techniques here, especially the idea of higher level logical types, I think are very encouraging. And again, we do appreciate Janet and Michael's suggestions for future work in this area. So are there any comments? We got about 3 minutes left.
Comment.
Yes.
It seems to me that you should point out that this deals with the description of a thing, such as ultimately a system, but not the prescription of a system.
Okay. I'll think about that, Jack. I'm trying to figure out what it means, but yeah.
Well, I think until you get a well-grounded, commonly understood description, your prescription methods are not going to succeed. I think this is more a matter of, Jack, as you've discussed, the whole systems modeling approach that people need to start with a clear, well-grounded, common model of the problem system, and that then they can then they have some hope of manipulating that with the computer-aided procedures and move into the prescriptive. But I guess didn't Warfield develop as Kevin was talking about last time, the optionatique, the ability to identify
Right. That's a kind of follow-on technique, and so that goes into the quads and the tapestries, which we haven't talked about here. Where I would like to, focus on this, and once we kind of get this working a little bit better, then yes, everything you're talking about there, Janet, is true. That you go and then once you've identified the problems, then you think about, what are your options to solve these problems? So yes, that's
and
all parts of it.
the clarifications that you're providing here, the better grounding,
Joe,
would carry over.
just make a quick comment on or are you talking still with?
No, go ahead, Kevin. Go ahead.
Just a quick comment on the bit of logic you had for the part of relationship.
Mhm.
There's like a dozen different logical formalisms for different part of mereologies. And depends on which one you pick, you apply different different of the logical properties. What you had is one of them, but there's others.
Right, Kevin. And so what you've now just pointed out is that's the reason for higher order types theory. Because once you have very specifically identified which type you're talking about, right, then you can apply that logic. That's a very good point, Kevin. So are we, so no, the 4th, so the 18th, are we talking on the 18th, Kevin?
Yeah.
Okay, so Kevin's on the 18th for continuing with playbook, and we'll just kind of keep going from there. Thanks for attending. Any final? Okay, well, we'll see you all on the 18th. Have fun.
Okay, bye.
Applause.
Thank you all.
Bye-bye.